This is Emad Mirabi. Let's start the second session of 10th grade physics. In this session, we'll talk about prefixes of units, scientific notation, and then we want to cover measurement and sources of error in measurement, and what is the difference between accuracy and precision. Okay, let's start. So we have some prefixes of units which enlarge or increase the size of the units. These are like deca means 10, hecto means 100, kilo means 1000, mega is million, giga is 10 to the 9, tera 10 to the 12, peta 10 to the 15, exa 10 to the 18. So reading them, it will be deca, hecto, kilo, mega, giga, tera, peta, exa. Okay, so these are enlarging prefixes of units. These prefixes of units, if they come before a unit, they will enlarge or increase the size. For example, a decameter means 10 meter. A hectopascal means 100 pascal. Hecto means 100 and it comes before pascal. That's why it's called prefix. Okay. We have some prefixes of units that decrease the size of units. They are deci, which is 1/10, centi is 1/100th, milli is 1,000th, micro is 1/1,000,000th, nano is 10 to the negative 9, pico is 10 to the negative 12, femto is 10 to the negative 15, and atto means 10 to the negative 18. So prefixes of units which decrease the size are usually shown by lowercase letters. So deci, centi, milli, micro, nano, pico, femto, atto. Micro, nano, pico, femto, atto. Okay, so we need to memorize these. For example, a microampere is 1/1,000,000th of ampere. Okay, so why we use prefixes? Scientists and engineers often deal with very large or very small numbers. Prefixes simplify expressions and avoid writing too many zeros. For example, instead of writing 0.000, so many zeros here, how many zeros? We have 8 zeros and 1. So it is 1 times 10 to the negative 9. We can say it is 1 nanosecond. Instead of writing so many zeros, we can say 1 nanosecond. So it simplifies. Instead of writing 1 and 9 zeros at the right, hertz, we can say it is a gigahertz. Another way to avoid too many zeros when dealing with very small or very large numbers is using scientific notation. For example, in this case, we can use 10 to the negative 9 seconds. Or in this case, we can write 10 to the 9 hertz. Or 1 times 10 to the negative 9. Or 1 times 10 to the 9. So this is scientific notation. Okay, frequency of a light is 4.3 times 10 to the 14 hertz. State in terahertz. So we need to memorize the prefixes. We will need to know that mega is 10 to the 6, giga is 10 to the 9, mega, giga, tera, peta, exa. So tera is 10 to the 12. So this is what we need here. We want to state it in terms of terahertz. So let me write it like this: 4.3 times 10 to the 12, 10 to the 2 times 10 to the 12. So I broke down 10 to the 14 into 10 to the 2 times 10 to the 12, and then I combine these two, so I can write 430 times 10 to the 12 hertz, which can be written as 430 terahertz. Okay, so I have to write the unit of hertz here. Hertz. So instead of 10 to the 12 hertz, we wrote terahertz. Okay, so both scientific notation and prefixes of units can be used.